Dr. Babasaheb Ambedkar Open University.
Namaskar dear students, I am Dr. Himanshu Patel and I am working as an assistant professor in School of Computer Science of Dr. Babasaheb Ambedkar Open University, Ahmedabad, and I am your instructor for these modules. In today's session, we are going to discuss about two important topics, that is networking and telephony API. So let us start. In today's session, we will learn about how to check for network connection, how to perform network operation and manage network usage. We will learn about Android NFC. We will also learn about Android Wi-Fi, and we will get overview of Android telephony API. And at the end, we will take demonstration for network connection and telephony API. So let us start. Learning objective for this session is, after studying these modules, learner should be able to get familiar about Android networking terminology. They can check network connection status. They can also perform network operation, and one can define NFC, that is near field communication, and they can understand the steps for Wi-Fi scanning process. Basically, there are three steps that we are going to learn in this session. And at the end, we will discuss briefly about TelephonyManager class. So let us start our discussion with network connection. Android lets your application connect to the internet or any other network and allows you to perform network operations. A device can have various types of network connection, such as Wi-Fi or mobile network connection. And to perform network operations in your application, your manifest must include some permissions. So remember, you have to use network state access permission, right? And in addition to providing standard network connectivity, Android provides APIs to let your app connect and interact with other devices with protocol such as Bluetooth, NFC, Wi-Fi, P2P, USB and SI. So how can we connect to the network, right? So to perform network operation in your application, your manifest must include some permission. Now what are those permissions? As we mentioned earlier, you should have android.permission.access network state permission should be there, and in addition to that we should have internet permission. So don't forget to include these permission in your manifest file so that you can actually connect to the network and access its state. Now, what are the network state? The first state is connected. It means we have already established connection. Then during connection establishment, we have in connecting state. When you remove or disconnected, you are in disconnected state, and while disconnecting, you can have disconnecting state, and if you are removed from some Wi-Fi or network, you are in suspended, and you can also have in unknown state. So these are the basically various kind of states that network connection can have. Now, how to check network connection, right? So, before you perform network operation, it is good practice to check the state of network. Actually, network may be available, but you don't have permission to connect to that network, or network may not be available at all. So, you have to check the state of network connectivity. If network connection is unavailable, your application should respond gracefully that no network connection found to establish connection. Then, to check the network connection, you typically use the class that is Connectivity Manager, which answers queries about the state of network connectivity, and it also notifies the application when network connectivity changes, whether it is available, unavailable, or it may be something else. Then we have second class, that is network info. So it describes the status of network interface of given time, whether it is mobile or Wi-Fi, etc. So these are the class that we are going to use to check network connection. Now we actually look at the code to check network connection. So the first thing you have to do is you have to declare one object of type Connectivity Manager that we have already learned. So using get system service and as an argument connectivity service, you can get or create instance of Connectivity Manager. So these lines actually create instance of Connectivity Manager, which actually refers to connectivity services. Then we have declared two Boolean variables. So whether it is Wi-Fi connection or whether it is a mobile connection. So initially it is set to false. If we have Wi-Fi connection, we will set it to true. If it is mobile connection, we will set it to true. Now, the second object is of type network. Now here I have written for each loop. So we have created one object of type network which get all the networks using Connectivity Manager one by one and check whether that connection is Wi-Fi or mobile. So inside network we get each kind of networks, and inside for loop we have created one object of network info and it is assigned to Connectivity Manager dot network info. Now which network information we want to retrieve? So whatever connections available, that means all networks available, it takes those connections one by one in network object, and each network information is stored in a network info object. Now we write down if network info dot get type is equal to Connectivity Manager dot type Wi-Fi. So type Wi-Fi constant is available inside Connectivity Manager and it refers to Wi-Fi connection. So if that network type is Wi-Fi, then we write down is Wi-Fi or equal to network info dot is connected. That means we have connected to that network. Then it is set to true. Now, if network info dot get type is equal to type underscore mobile, which is constant available inside Connectivity Manager, and we have write down is mobile connection or equal to network info dot is connected. That means either we have connected with Wi-Fi or we have connected with mobile. So whatever type of connection we have, based on that Boolean is set to true. and inside locket window we will display whether Wi-Fi connected, so it is true or false. And remember, the first argument is missing here, which should be some tag to filter inside locket window. So this is a basically code to check network connection. First, we create instance of connectivity manager, and then we fetch all networks one by one and get network info, and we check whether we are connected to that network or not, and based on connectivity we have store true or false inside that boolean variable, and that we will display inside locket. So after executing this code we will get information whether we have to connect it to either of the network or not at all. If both are full, that means we have not connected to any network, right? So this is how we can check network connection. Now, how to manage network usage, right? So to write an app that supports network access and managing network usage, your manifest must have the right permission and intent field. So you should have these permission: android.permission.internet, which allows application to open network socket. Then you should have second permission, that is access network state, which allows application to access network information about networks. And you can declare intent filter for the action underscore manage underscore network underscore usage action to indicate that your application defines an activity that offers option to control data usage. And you should also write to show settings for managing the network data usage of a specific application. So when we write down these two permissions and intent filter inside our activity, it means these activity can have code to manage network usage. Now let us understand how can we perform network operations. So various kind of operation we can perform after checking that your connection to the internet. You can perform various kind of operations. Now what are those operations are? Android provides HTTP URL connection class and URL class to handle these operations. You need to instantiate an object of URL class by providing the link of website. So basically these class object establish connection with network, but you have to provide address or URL for that connection. The first method is connect. So these method open connection so that its resource may be either reused or closed. So connect is used to connect to that remote URL. Then we have disconnect method to release the connection so that its resource may be either reused or closed. Then we have get request method inside HTTP URL class that returns the request method, which will be used to make the request to the remote HTTP server. Now there are many kind of requests like get, post, delete, put, etc. So these method returns request method. Then we have get response code. Earlier we have already used this HTTP connection class to download JSON file, right? So at that time we have checked whether that response is okay or not. So there are many constant defined inside HTTP URL connection class which returns response code. So these method returns response code written by the remote HTTP server, so that you can know whether that link is available, whether that page is temporarily moved, whether it is available, whether it is unavailable, whatever status is that you can know using this response. And we have set request method, and inside these method you have to specify method that you want to use. So these method sets the request command which will be sent to remote HTTP server, which may be get, post, add, options, put, delete or trace. So any of method, generally we use get or post, but you can use any of these method as a argument. And finally, we have method called using proxy, which returns whether this connection uses proxy server or not. So these are the method of HTTP URL connection class that you can use to perform various kind of network connections like connect, disconnect, knowing and setting method, request method, and whether we are using proxy or not. So friends, we have understand how to check whether network connection is available or not and whether we have connected to that network or not. Then we have discussed what kind of permissions and intent filters are required to manage network usage. Now we are going to discuss NFC, that is near field communication. We can say NFC is a set of short range wireless technology typically requiring distance of 4 cm or less to initiate connection. That is why its name is near field communication. Two devices must be very close to each other, that is less than 4 cm distance between two devices to actually initiate connection. It allows you to share small payload of data between NFC tag and Android powered device or between two Android powered devices, right? So basically it is for allowing small exchange of data between two NFC compatible devices. Now it share data using tag. So tag can range in complexity. It is very simple. The data stored in tag can be written in NFC data exchange format. Now short form of NFC data exchange format is NDEF. So remember, whenever we refers to NDEF, it means NFC data exchange format. Now NFC provides 3 mode of operation. So Android powered device with NFC simultaneously support 3 main mode of operation. First is called reader writer mode, which allows the NFC device to read and or write passive NFC tags and stickers. The second mode is called P2P mode, which allows the NFC device to exchange data with other NFC peers. This operation mode is used by Android Win. The third mode is card emulation mode. It allows NFC device itself to act as an NFC card. The emulated NFC card can then be accessed by an external NFC reader such as NFC point of scale terminal. So in this case, NFC device is act as an NFC card. Now, what are the permissions required to use NFC? Now, before you can access device NFC hardware and properly handle NFC intents, it declares these items in your Android manifest.xml file that you can see on the screen. The first is we should declare uses permission, and it declares we want to use android.permission.nfc, and we should declare SDK, that is minimum SDK version should be 10, and we we have to specify that we want to use Android hardware.NFC and it requires must be true. That means only NFC compatible device can use NFC code. Now Android provides this package, Android.NFC package, for communicating with another device. Now it contains many classes, right? So first is NDEF, that is NFC Data Exchange Format Message, which represent immutable NDEF message. That means it cannot be changed. Then we have NDEF record class, which represent immutable record, and we have NFC adapter, which represent local NFC adapter, and we have NFC event to wrap information associated with NFC event, and we have NFC manager, which is high level manager used to obtain an instance of NFC adapter. And finally we have tag class, which represent NFC tag that has been discussed. So these are the various kind of classes provided by Android.NFC package that you can use to write applications which use NFC technology. Now these are the NFC tag intent filter. You have to declare these intent filter inside your manifest file so that one can understand that these applications can exchange NFC data. So first is action underscore NDEF underscore discovered, and it is used to start an activity when tag contains an NDEF payload. Then second is action underscore tag underscore discovered. It is used to start an activity if the tag does not contain NDEF data but is of non-technology. Then we have action underscore tag underscore discovered, which is started if no activity handles the action that is mentioned earlier. So these filter should be declared inside your manifest file so that other app can know whether your application and what kind of data can be managed by your application. So Android NFC must be used carefully and only if required, because it is new technology. Every device does not support NFC. NFC hardware must be there inside phone to use NFC technology, right? The next topic we want to discuss is Android Wi-Fi. You can use Wi-Fi scanning capabilities provided by Wifi Manager API to get list of Wi-Fi access points that are visible from the device. Now, your phone has an inbuilt app for Wi-Fi scanning process. But if you want to implement these functionality inside your app, then you have to implement Android Wi-Fi scanning process. So basically, there are 3 steps involved in Wi-Fi scanning process. First is registered broadcast listener for scan underscore result underscore available action, which is called when scan requests are completed, providing their success or failure status. So this is a first step, right? Now for device running Android 10, which is API level 29 and higher, these broadcasts will be sent for any full Wi-Fi scan performed on the device by the platform or other apps. Apps can passively listen to all scan completion on device by using the broadcast without issuing scan of their own. So we will learn how to register broadcast listener, but the very first step is to register broadcast listener for these actions, right? The second step is actual request scan using Wifi Manager start state. So basically, this is actual process for scanning you have to make sure to check the return status of the method, since the call may fail for any of the reason. Now, why you cannot connect to Wi-Fi? The scan request may be throttled because of too many scans in a short time. The device is idle and scanning is disabled, and Wi-Fi hardware reports scan failure. There is no Wi-Fi available. So for any of these reasons, the Wi-Fi scanning may fail. So you have to capture result written by this scan process, and once you get scan result using Wifi Manager.getScanResult, using written scale result, you can decide from most recently updated result, which may be from previous scan. If your current scan has not completed or succeed, remember, it means that you might get older scan results if you call this method before receiving a successful scan result available action. That means once that scanning has started, it takes some time to get all the results. Now, meanwhile, if you start another process, it might possible that you get old scan results, right? So for that, you have to ensure that previous scan has completed or succeeded. So these are the 3 steps involved in Wi-Fi scanning process that we are going to demonstrate in coding part. Now we want to use Android Telephony API to get telephony related information. So telephony basically is a general term that refers to electrical voice communication over telephony. Now there are 2 popular networks are there. So Android device generally use mobile telephone network, specifically either GSM or CDM. So global system for mobile communication, that is GSM, or another technology CDM, that is code division multiple access networks, right? So your device may either use GSM or CDMA technology for voice communication. Android provides TelephonyManager class that supplies information about many telephony related details on the device, such as phone properties, and obtain phone network state information. So using these class, you can get these information, either phone property or your network state information. You can attach phone state listener event to listen to phone by using the manager, and attaching phone state listener makes your application aware of when the phone call gains and loss services and when call start, continue or end. So if you want to perform some action based on either call starting or call ending or in between call, then you have to listen to these events using phone state listener. The telephony provides contains data related to phone operations, specifically SMS and MMS messages, access to the APN list, including MMSC to use, and the service state. It is available inside Android.telephony package, which provides API for monitoring the basic phone information such as network type that we have discussed earlier and connection state plus utilities for manipulating phone number settings, etc. Using these class, you can listen to various call events, you can get telephony information, you can send SMS programmatically, or you can know when particular SMS is received, etc. So there are phone related manifest permissions required to do all these operations like call phone, to initiate phone call without user confirmation in dialer, then call privilege to call any number including emergency without confirmation in dialer. Then we have modify phone state to allow the application to modify the phone state. For example, to turn the radio on or off, we have permission process underscore outgoing underscore calls that allows application to receive broadcast for outgoing calls and modify. And we have read phone state to allow application to read the phone state. So these are the various phone related manifest permissions required by your app if you use any of these functionality, right? So friends, in this module, we have learned about very important topic, that is how to establish network connection, how to use Wi-Fi in your application, what is NFC, what is Android.NFC package, what are the classes that is available inside NFC package, what are the various modes of operation for NFC communication or near field communication, and we have also discussed process for scanning Wi-Fi. I hope you enjoyed this session. Thank you and happy learning.
स्वाध्यायः परमः